Welcome to lecture 15 of plant design and economics. As of now, in this week, we have talked about capital investment. We have talked about fixed capital investment. We have talked about working capitals. Now, in today's lecture, we will learn how to estimate cost of product. So, total product cost estimation is today's topic. Estimation of total product cost, and then we will take numerical examples. In fact, today we will take several numerical examples to understand the concepts. A company earns revenue from sale of the products produced by the plant. A company can have multiple products, a company can have a single product and may or may not have few byproducts as well. So, annual sales revenue in rupees per year will be sum of sales of product in kg per year multiplied by product sales price in rupees per kg. So, you will get sales revenue in rupees per year. The rates of production of byproducts are determined by the chemistry, operating characteristics and mass balances for the process. We will talk about byproducts soon in some more detail. For preliminary economic analysis of a process, the production rate of the plant in the first year may be taken as 50% of the design capacity. This is because in the first year, the production rate during the startup period will generally be low because the plant may not run at its full design capacity, and also the length of the startup period is uncertain. So, in the first year, it is advised that you consider 50% of the design capacity. Second year onwards, you may consider that the plant will be running in full design capacity. You have to give downtime allowance. Downtime allowance is required because no process will run for all 365 days, maintenance are required. So, about 10% of 365 days for a continuous process is generally allowed. So, actual operating time will be approximately say 330 days per year. For 90% operating time, the hourly production rate will be annual output rate in kg per hour multiplied by 0.9 times 8760 hours per year. Note that there are 8760 hours in a year. So, for 90% operating time, you will get the hourly production rate as annual output rate in kg per hour multiplied by 0.9 multiplied by 8760 hour per year. Now, we are talking about byproduct. With desired out product, some byproducts are also formed by the main reaction stoichiometry. This is unavoidable unless you find new chemistry to produce your product. Some byproducts are also produced from feed impurities or by non-selective reactions. These stoichiometric byproducts are generally recovered and sold, otherwise waste disposal cost will be excessive, you will also lose revenue. Some examples of stoichiometric byproducts are given here in this table. From cumene and air, we produce phenol and we get acetone as byproduct. Propylene oxide is produced from propylene, ethyl benzene and air, and styrene is obtained as byproduct. Vinyl chloride monomer is formed from ethylene and chlorine, and hydrochloric acid is obtained as byproduct. hydrogen is produced from methane and steam, and carbon dioxide is obtained as byproduct. So, we obtain revenue by selling products, main products, and also by selling sellable byproducts. Now, we can also earn revenue from some one time events, such as you sell obsolete equipment, those equipment which are no longer usable. So, you can sell obsolete equipment, recovery of working capital after the plant is shut down or the life cycle of the plant is over. So, from such one time events also you will earn some revenue, but these are all one time events. Regular events are sale of regular products as well as sale of sellable byproducts. Now, let us talk about estimation of total product cost. Total product cost depends on all cost of operating the plant, selling the products, recovering the capital investment, and contributing to corporate functions such as management, research and development, etc. Total product cost is generally divided into two categories: manufacturing cost and general expenses. Manufacturing costs are also known as operating cost or production cost. So, we have two types of product cost. One is manufacturing cost or operating cost or production cost, and the other category is general expenses. Now, the manufacturing costs are further subdivided into three different types: variable production cost, fixed cost or fixed charges, and plant overhead cost. So, total product cost is divided into manufacturing cost and general expenses, and manufacturing cost is further subdivided as variable production cost, fixed cost, and plant overhead cost. Now, let us talk about these three manufacturing costs in some more detail. Before that, this total product cost you can calculate on various bases, such as daily basis, unit of product basis, as well as annual basis. Among these three, the annual basis is best option and most frequently chosen. So, now we will talk about these three different manufacturing costs in some more detail. We start with variable production cost. Variable production cost include expenses directly associated with the manufacturing operation and are proportional to the plant output or operation rate. So, in a very short sentence, variable production cost depends on the production rate of the plant, and they will include expenses which are directly associated with the manufacturing operation. Variable production costs involve expenditure for raw materials including transportation, unloading, etc., direct operating labor, supervisory and clerical labor directly applied to the manufacturing operation, utilities, plant maintenance and repairs, operating supplies, laboratory supplies, royalties, catalyst, solvents, etc. Variable costs are mainly determined by the choice of feedstock, process chemistry, plant location, and variable cost can be reduced by more efficient design or operation of the plant. What about fixed cost or fixed charges? As the name suggests, fixed cost or fixed charges are expenses which are practically independent of production rate. They are kind of fixed, independent of production rate. Expenditure for depreciation, property taxes, insurance, the loan interest that you have to pay, the rent that you have to pay are usually classified as fixed charges. These charges, except for depreciation, tend to change due to inflation factor. We have talked about economy of scale in total capital investment. We talked about this when we talked about capacity. So, higher capacity leads to economy of scale in total capital investment. So, that is an incentive for building chemical plants with large capacity. So, if you build chemical plants with large capacity, we have seen in previous classes that there is something called economy of scale in total capital investment. So, building large chemical plants are favored compared to small scale plants, because you have economy in total capital investment. Another incentive in building large chemical plants lies in the fixed cost. As plant size is increased, labor, supervision and overhead costs usually do not increase proportionately. They will increase, but they will increase to less extent, and hence the fixed cost per unit of product will decrease. So, this is another incentive for building chemical plants with large size. Fixed costs are not easily influenced by better design or operation of the plant, other than improvements that allow the plant to be operated safely with a smaller workforce. Now, the third type of manufacturing cost, plant overhead cost. Plant overhead costs are for hospital and medical services, general plant maintenance and overhead, safety services, payroll overhead including social security and other retirement plans, medical and life insurance and vacation allowances, packaging, restaurant and recreation facilities, salvage services, control laboratories, property protection, plant superintendents, warehouse and storage facilities and special employee benefits. So, these all will come under plant overhead. These costs are similar to the basic fixed charges, since they do not vary much with changes in production rate. So, it is only variable cost or the production cost that is proportional to the rate of production. Now, the total product cost, as we have seen in previous slides, it is sum of manufacturing cost and general expenses. So, total product cost is equal to manufacturing cost plus general expenses. Manufacturing cost is sum of direct production cost, fixed charges and plant overhead cost. So, we have seen there manufacturing cost can be divided into three categories: production cost or direct production cost, fixed charges and plant overhead cost. Now, direct production cost or that variable production cost, this is about 66% of total product cost, and raw materials, operating labor, direct supervisory and clerical labor, utilities, maintenance and repairs, operating supplies, laboratory charges, patents and royalties, expenses for all these will come under direct production cost. Fixed charges will be about 10 to 20% of total product cost, and the items that come under fixed charges are depreciation, local taxes, insurance, rent, interest that you pay, and plant overhead cost will be about 5 to 15% of total product cost. And the plant overhead cost will include cost for general plant upkeep and overhead, payroll overhead, packaging, medical services, safety and protection, restaurants, recreation, salvage, laboratories, storage facilities, etc. Now, we talked about free manufacturing cost. Now, general expenses. General expenses is sum of administrative cost, distribution and selling cost, research and development cost, and it will be about 15 to 25% of the total product cost. Administrative cost will be about 2 to 5% of total product cost. Distribution and marketing cost will be about 2 to 20% of total product cost, and research and development cost will be about 5% of total product cost. So, this is how you will be able to estimate the total product cost from sum of manufacturing cost and general expenses. Now, let us define three terms: gross profit, net profit and cash flow. Gross profit, also known as gross earning. Gross profit in year J, depreciation not included, is defined as difference between the product sales revenue and the total product cost. So, gross profit or gross earning is equal to the product sales revenue minus the total product cost. If you include depreciation, so gross profit or gross earnings, depreciation included, will be the product sales revenue minus the total product cost minus the depreciation. When you talk about in a particular year, say year J, all these values are calculated in that particular year J. Net profit or net earnings will be the amount retained of the profit after income tax is paid. Let us say income tax is paid at the rate of 5 and capital G is the gross profit, depreciation included, then net profit will be capital G into 1 minus 5. So, it is basically the amount that you retain after income tax has been paid. The cash flow resulting from process operation, which will be returned to the capital source or reservoir or the company treasury, will be the net profit plus depreciation. So, these are some of the terminologies that you need to remember. Now, we define one factor known as on stream factor or simply stream factor. As we have already discussed, no plant is capable of running all of the time. So, no plant will be capable of running 365 days in a year, because there will be mechanical breakdown, there will be requirement for maintenance, there may be power disruption, shortage of feed materials or cells, cleaning or catalyst change, and so on and so forth. So, these will cause periodic shutdown of the plant. The fraction of time that the plant is operating in a calendar year is known as on stream factor or stream factor. So, stream factor or on stream factor is nothing but the fraction of time that the plant is operating in a calendar year, that is 365 days. So, stream factor is defined as number of days plant operates per year divided by 365. So, what are the typical values of stream factors for chemical process industries? Reliable and well managed plants will typically shut down for 1 to 2 weeks a year, and this will give a high stream factor value. Less reliable processes may require more downtime and hence relatively lower stream factor value. Typically, stream factor for continuous processes will be around 0.90 to 0.96. 0.96 for highly reliable and well managed company or plants. Manufacturing and associated costs are most often reported in terms of rupees per year. This is the basis which is most preferred. Information on a process flow diagram is most often reported in terms of kg per hour or kilomole per second, that means in mass per time unit or mole per time unit. Stream factor is very useful for calculation of yearly cost of raw materials or yearly cost of utilities from process flow sheet diagram. So, how we do that? Let us take a very simple example. So, again let us consider hydro dealkylation of toluene. We have discussed this when we talked about process flow sheet. So, look at the stream number 1. This represents toluene stream. And you know that such flow sheets are associated with a stream table which has all the details informations about all the streams. Now, the flow rate of toluene is 10,000 kg per hour. It is not shown here, but let us say that a stream table is there, and from that stream table I read the toluene feed stream is 10 ton per hour or 10,000 kg per hour. Cost of toluene is around 60 rupees per kg. So, what will be the annual cost of toluene? Assume stream factor of 0.9. So, this stream factor will allow you that how much toluene needs to be processed in 1 year. And then from the cost of toluene rupees 60 per kg, we will be able to find out the annual cost of toluene. So, the annual cost of toluene will be 24 hours per day into 365 day per year. This gives you number of hours per year. When you multiply that by 0.9, so this takes care of the downtime. So, now we have number of actual operating hour per year. When you multiply that by 10,000 kg per hour, you get how many kg per year, and you multiply with the cost of the toluene rupees 60 per kg. So, you get the cost in rupees per year. So, this is the use of the stream factor in calculation of annual cost of a reactant. You can also find out the annual cost of utility from process flow diagram. Again, let us consider the same process flow diagram of hydro dealkylation of toluene. Consider the feed preheater E101, where you use high pressure steam to heat the mixed toluene and hydrogen stream. Now, here we assume a stream factor of 0.95. It is given that heat duty for the heat exchanger E101 preheater is 15.19 gigajoule per hour. The cost of high pressure steam is given as rupees 400 per gigajoule, and also heat of vaporization is given as 1698 kilojoule per kg. We have to estimate the amount of steam required per year and the annual cost of steam for the feed preheater. So, you can write down a simple heat balance to find out the amount of steam that is required. So, heat duty 15.19 gigajoule per hour will be equal to amount of steam multiplied by heat of vaporization. Heat of vaporization is given, so amount of steam can be found out. So, amount of steam can be found out as 2.485 kg per second. Now, to calculate annual cost of steam for the preheater E101, you can again find out using steam factor. So, you know the heat duty is 15.19 gigajoule per hour, and you know the cost of the high pressure steam as rupees 400 gigajoule per hour. Then you multiply this 15.19 with 400 and with the actual operating number of hours. So, that gives you 5 crore 5,64,472 rupees per year. Now, let us take some numerical examples. A polymer plant with a production capacity of 10,000 tons per year has an overall yield of 70%. On mass basis, kg of product per kg of raw material. The raw material costs rupees 50,000 per ton. A process modification is proposed to increase the overall yield to 75% with an investment of rupees 12.5 crore. In how many years can the invested amount be recovered with additional profit? So, your production capacity is fixed at 10,000 tons per year. Your current yield is 70% and a process modification is proposed to increase the overall yield to 75%. So, this increase in yield will save money because it will save raw materials. So, the process modification will lead to lower consumption of raw materials and thus savings. So, let us first find out the annual cost of raw materials with current 70% yield. So, that can be found out by first dividing 10,000 tons per year with 0.70, the yield. So, that gives you the amount of raw material, and then you multiply the cost of the raw material per ton. So, you get the annual cost of the raw material with 70% yield. The same way you find out the annual cost of the raw material with 75% yield. So, what is the saving? The difference between these two. So, annual savings due to process modification is 71.43, which is the cost 70% yield, and 66.67 crore is the annual cost with 75% yield. So, I get 4.76 crore as annual savings, and I am investing 12.5 crore for the proposed modifications. So, the number of years required to recover it is 12.50 divided by 4.76, which is 2.63 years. So, that is the answer. Let us take another example. A plant manufactures compressors at the rate of n units per day. The daily fixed charges are rupees 20,000 and the variable cost per compressor is rupees 500 plus 0.2 into n to the power 1.3. It is a function of n, which is the number of compressors being manufactured. a day. The selling price per compressor is rupees 1000. How many compressors should be manufactured to the nearest integer in order to maximize the daily profit? Now, let us consider that the number of compressors to be manufactured to maximize daily profit is n. So, now we find out the total profit, which will be a function of n. Then take the derivative of that function with respect to n, set that equal to 0, solve it, and we will get the optimum value of the number of compressors that needs to be manufactured per day. So, profit is selling price minus production cost. Production cost is sum of fixed charges per variable cost. So, which gives me this equation. So, n is the number of compressors to be manufactured to maximize daily profit. So, 1000 into n is the selling price, daily fixed charge is rupees 20,000, and this is the variable cost for n units. Because the variable cost per compressor is given as 500 plus 0.2 into n to the power 1 by 1.3. So, you have to multiply this quantity with n to get the variable cost for n compressors. So, this is the daily profit. So, note that this is a single variable function, it is a function of n. So, you take the derivative of this with respect to n and set that equal to 0. So, if you do that, you get the optimal value of n as 217. It has been rounded up to the nearest integer value. So, let us take another problem. The total cost of an equipment in terms of the operating variables x and y is Ct equal to 2x plus 12,000 by xy plus y plus y plus 5. What is the optimum value of the total cost Ct? This is a problem in optimization. So, the cost function is a two variable function. So, Ct is a function of x and y. So, what you have to do is you have to set the gradient of Ct, which is del Ct del x and del Ct del y equal to 0. So, by setting this equal to 0, you will get two equations. You have to solve these two equations to get x and y, which will give you the optimal values of Ct when you put these values of x and y into this expression for Ct. So, del Ct del x equal to 0 gives you x square y equal to 6000, del Ct del y equal to 0 will give you xy square equal to 12,000. Solve these two equations simultaneously, you get the value of x as 14.42 and y as 28.84, and on substitution you get the optimum value of total cost as 91.53. In this expression you put value of x and y. So, this is how you can solve this. Let us move on to another problem. The annual fixed charges and the annual utilities cost of a distillation column being designed are expressed in terms of the reflux ratio as two expressions are given. So, how will you find the optimal reflux ratio that maximizes the total cost of the distillation column? So, you find out the total cost as sum of annual fixed charge and annual utility cost. Again look at this is a single variable function of reflux ratio R. So, find the optimal reflux ratio, you have to take derivative of this function with respect to reflux ratio R and set that equal to 0. So, take it as a homework and complete it. To check that the value that you get is really minimizes the function. You have to take higher derivative and ensure that R optimum is actually minimizing the function. So, now we will take the last problem. Annual capacity of plant producing phenol is 100 metric tons. Phenol sells at INR 200 per kg and its production cost is INR 50 per kg. The sum of annual fixed charges, overhead cost and general expenses is 30 lakhs. Taxes are payable at 18% on gross profit, assuming the plant runs at full capacity and that all the phenol produced is sold. What is the annual net profit of the plant in Indian rupees? So, this is a straightforward application of the definitions of gross profit, net profit, etc. We know this equation. So, gross profit or gross earning is equal to the product sales revenue minus the total product cost. So, find that. What will be the total product cost? 100 metric ton means 100 into 1000 kg and the phenol selling price is rupees 200 per kg. So, this gives you the product sales revenue and the total product cost is 30 lakhs, which is the sum of annual fixed charges, overhead and general expenses, and then this you get from production cost is rupees 50 per kg. So, this gives you 1 crore 20 lakh rupees as the gross profit. So, now you pay tax at the rate of 18%. So, the net profit is the money retained after that, which is computed as 98 lakhs 40,000. With this, we stop our discussion here.